Hello, everybody. Hello, everybody. Welcome to my channel. And my name is Toby Famutini, and I'm a safety engineer. What this channel is about, we're going to be talking mainly about safety engineering, about all the uh, topics on safety engineering, and I'm going to be sharing knowledge with everyone on different aspects of safety engineering, fire engineering, process safety, and loss prevention and technical safety. So yeah, everyone, of course, I don't claim to know everything, but so if there's anything you're not okay with video, you can send me a message or drop a comment, and I'll definitely reply to you. So today we're going to be talking about valves. It's very, very important in oil and gas. Valves are very, very necessary, and the various types of valves we have. I'm going to be showing you pictures and explaining the uses, the various types, showing what they look like in real life, and showing what they look like on the PNIDs. So when we look at a drawing, we can have an idea. We can know what the valve represents in the drawing, and also when we see it in real life we have an idea. Although some valves, all some kind of valves all look the same based on their manufacturer, but yeah. So let me just give a brief uh, definition of what a valve is all about, what it does and stuff. A valve is a device that regulates, directs, or controls the flow of a fluid, either gases, liquids, slurries, by an opening and closing or partially obstructing various passageways. Valves are fittings, really. They're fittings that go on pipings, that go on pipe. So let me give like an explanation of what a valve is, like a layman, like for a plumber, like a plumber that comes to your house and works on your pipe works for water to flow. It's it's a device he uses. That's the basic. I'm just giving a basic definition of what it is. So a valve could be like a tap, or if you look under your sink at home, you would see some tap-like should I say devices which you can open and close, which could actually stop water from flowing or make it flow faster, make it flow slower, or make it flow in a certain direction, either forward, backwards. And so those are like those are valves, but that's in normal piping at home for domestic use. So the kind of pipe for valves we'll be talking about are valves used in the oil and gas industry, and they're um, anywhere you see a pipe and you want to control the flow, definitely there would be a valve there to kind of work on it. So this is just a picture of a valve. This is what valves look like on PNIDs. PNIDs are called process and instrumentation diagrams, or we could call them PEFS. That's process engineering flow schemes. So this is what they look like when we look at them in our drawings, engineering drawings, and then this is what kind of what they look like in real life. And yeah, so this is more. There are lots and lots of various types of valves, thousand types of valves based on what you would need the valve to do. You can actually manufacturers actually create a valve to suit a need. So based on the need they want to use it for, they can actually create it. But I'm just going to be talking about the popular types of valves that you meet in your everyday oil and gas installations and facilities. So let's go down to the list here. So I said, firstly, I'd like to start with ball valves. So let me zoom in on this a bit. Yep. So let's go into this. Yeah, sorry for that slight delay. So this is a ball valve. I'm going to zoom in on it so you have an idea of what the logo looks like, or what the symbol is. This is a ball valve. This is how you would see it on a PNID or a process and instrumentation diagram. Yes, sorry about that. So a ball valve. So what a ball valve is, let me show you a picture of it. This is basically what it would look like. It's a valve. That's the lever or the control to open it or close it. And yet this is also a ball valve, depending on the size. Some of them are actually as tall as you, and some can be as can fit in your palm. So it just actually controls flow. So let me give a definition of it. A ball valve is a shut-off valve that controls the flow of a liquid or gas by means of a rotary ball having a ball. By rotating the ball a quarter turn around its axis, the medium can flow through or is blocked. So this is the valve now, and this is what you use to control it. When you turn it, a ball in there moves and allows flow to go across the from a from a point of higher resistance to a point of less resistance. It flows across. So that's what a ball valve does. And you see it a lot in process and instrumentation diagrams. You see them a lot everywhere there. So I could go down to part of my PNID where I'm sure you would see valves. This is just a PNID I've worked on, and there are always valves everywhere. So this is a ball valve. So if you close this, assuming flow is coming this way, you can see the lines. And if you close this valve, that means you wouldn't have any flow going into this vessel. And same here, this is already closed. When you see it shaded black, that means it's closed in the PNID. That means that's how it's supposed to actually reflect in real life. And yeah, so you close this, flow can get up to here, and it's open right now, so flow can get to this PSV. So yeah, that's what a ball valve does. It's manually operated. You have to actually go there to open it and close it on site, and yeah, so it would restrict flow or allow flow to go from one point to another. Then we would be looking at the next we'll be looking at is a butterfly valve. Now, a butterfly valve, this is what it looks like in real life. So when you see it in a facility, you might just, because this part will be part of the piping. So you would, what you would see is this and the rotating lever. You would just see this, but you might not be able to immediately identify it if you're kind of new in the oil and gas. So it could have this wheel to control this, and it could have just a lever to that you turn. It's a quarter turn most times. This is the symbol for it. This is the logo for it, for a butterfly valve. And you find them being used in a situation where you have to quickly open or quickly shut off flow to in a pipe. And they're used a lot in fire water installations because you have to a lot of times you have to quickly open for to allow flow to replace or close them quickly, allowing isolation. So a butterfly valve, what's its use? Let me give a proper definition. And this is what it looks like. As I said, a butterfly valve is a quarter turn rotation motion valve that is used to stop, regulate, and start flow. A butterfly valve has a disc which is mounted on a rotating shaft. When the butterfly valve is fully closed, the disc completely blocks the line. When it's fully open, it allows flow to go across. So that's what a butterfly valve does. It allows you to a quarter turn and quickly open a close section of piping. So that's that for butterfly valves. And then I want us to look at check valves. Check valves. On the PNID, of course, let me show you what a butterfly valve looks like on the PNID also. I want you to catch that. This is it here, a butterfly valve. So you would see it a lot of time too in drawings, in PNIDs, and what it just means is that I'm not, I can quickly picture one here, although I'm sure we would have a couple lying around. Okay, let me run back and go to the next valve. So the next valve I will be talking about is what we call a check valve, or sometimes we call it an NRV, or sometimes we call it a non-return valve. NRV means non-return, or we could call it a check valve. Now, what a check valve does is that it actually allows flow in just one direction. So let's say you have a piping setup or installation where you want flow to only go, you don't want it there to be any kind of reverse flow, you want the flow to only move in one direction. You use a check valve for that. You put it in. So okay, yeah, so this is what it looks like. If you look at this well, it'll allow flow to go from here to this direction only. If the flow wants to come back, this closes shut and you wouldn't have any backflow. So it's to stop flow going backwards, and it's very useful, especially in time like situations where you have a pump and you don't want cavitation. So you don't want flow going backwards into the pump and turning the gears the other way around. That could cause cavitation. So that's what a check valve is, or that's what a check valve does. Let me show you. Okay, I had some pictures here. Yeah, pictures here of a check valve. This are check valves. So you can, as you can see this now, it would allow flow to go this way, but it wouldn't allow it to push this ball back up and go this way. So it's a very valve that's used a lot of times, and it's very popular in the oil and gas industry. Let me go through this and see if I can pinpoint a place where there's a check valve. Yep, this is one here. So because you don't want flow going backwards into this pipe, into this pump, you have a check valve. That's what it's for. Okay, so let's move quickly to the next. And yeah, so I'm going to be looking at a gate valve now. This is the logo for a gate valve here. It has a line in between, and it's also used, it's kind of like a normal manual valve. And let me give a definition for it. A gate valve, generally, it's the most common type of valve that's used in a process plant. It's a linear motion valve used to start or stop fluid flow. These valves are either in fully open or fully closed position. When the gate valve is fully opened, the disc of a gate valve is completely removed from the flow. So this, you can open it partially, you can open it slightly to restrict flow or control the flow. It has to be either totally open or totally closed. So these are pictures of it. This is what it looks like on an installation. Yeah, so this is it. When you're going around a facility, you see something like this, you have an idea that it's a gate valve. It has this kind of raised path where the plate goes into when it's open or when it's closed. This is a gate valve. This is the symbol for it, gate valve. And these are all gate valves here. So you can open it and it fully opens or fully closes and allows flow to go across. So yeah, that's a gate valve. And then I would explain what a plug valve is. A plug valve. This is it here. A plug valve is a cone or cylinder shaped valve that uses a rotator inside the valve body to control the flow of fluids. Plug valves have at least one hollow passageway to allow flow through the open valve, most often horizontally. This type of valve is especially useful for high pressure scenarios. So they use this to control high pressure a lot of times. It's not too often that you see it everywhere, but it's used quite a lot in the oil and gas industry. Let me give you a picture of it. Plug valve. Yeah, so this is what plug valves look like. They look like normal valves because based on but you would see that they have this kind of bend in them, which is useful when controlling high pressure. So this is a plug valve. Yep. So there are lots of pictures of it. Flow goes one direction, comes out the other. So this is plug valves. This kind of like um, bend or dents, or should I say molding of the metal. Generally, kind of, it's not all the time, but when you see it good number of times, it's for plug valves. Then I would go to a globe valve. So what's a globe valve? A globe valve is linear motion valve, and it's primarily designed to stop, start, and regulate flow. The disc of a globe valve can be totally removed from the flow path, or it can completely close the flow paths. They could be used for isolation or throttling. Now let me show you a picture of what a globe valve looks like. Do I have one here? Okay, I can't find any here. Go out. Okay. So what a globe valve does is that it's very similar to a gate valve, but gate valves are only used for on or off to allow flow fully or flow to stop totally. And whereas globe valves can be used for that and also can be used for flow regulation. Gate valves offer very little resistance to fluid flow when they're fully open and have small pressure drop across the valve. So gate valves generally are cheaper than globe valves because globe valves allow you an additional functionality, to control the which is to control flow also. So what haven't I talked about? Okay, I haven't talked about DBB. That's what you call double block and bleed. Now, this kind of valves are very necessary in the oil and gas industry. And let me look for the the logo for a double block and bleed. Yeah, this is a double block and bleed. What it means is that it's used for positive isolation, which means you want to actually just run some maintenance or do some work on a particular piece of equipment, and it could be a high pressure line, or it could be a high pressure line, or it could be there's a lot of fluid in it. So what you want to do is you want to stop flow on both sides and allow the pressure and the fluid in there to drain out through a valve in the middle. So it's as an arrangement of valves, three valves. There's one on the left, there's one on the right, one where flow is coming from, one where flow is going to, and then when you close the two of them, it it allows you to bleed whatever is left in the pipe in between. So it could be a lot of high pressure or a lot of liquid in there, so you have bleed it out, so you can now actually work on this equipment without without any problems. So you close the one on the left, you close the one on the right, and then you bleed the one in the middle. You open it out and let the flow go all in there. You drain out the fluid. So it's just like this arrangement here. Look at it. So this is it. So you close this, and then flow goes across. So that's what you call a double block and bleed. Those kind of valves are very necessary during maintenance when you have work to do. Let me look at it here. Let me search for it here. There should be an arrangement somewhere in here. Let me check. DBBs. There a lot of times they used around they used liquid outlets to allow flow of a liquid. Let me check around. Sorry for the delay. Oh, mm, yeah, I can't find any now, but I'll look for that. And if you have any questions or any comments, you can send me a message or drop a comment under the video, and I would give you a full explanation and also send you links and documents just to give you a better explanation. Now, these are very necessary to know this when you're in a hazard, because I facilitate hazards, and it's necessary to know these valves and the uses so that when you come across them, you can actually add more value to the hazard by suggesting you add this or remove that, or instead of using this valve that only has this function, you can put a valve that would do two, three more things. And if it's not necessary, then don't waste the money or doing what we call an overkill design or over designing the plants, like putting um should I say like globe valves everywhere when you can just use a normal ball valve, which wouldn't be that expensive. So next, um, let me just give a definition of what a DBB is, an official definition of what a DBB is. It operates on the principle that isolation can be achieved from both the upstream and downstream process flow pressures. This is achieved by two ball, either gate or globe or needle valves um, in series. It is a single, and sometimes it is a single valve with two sitting surfaces that in the closed position provides a seal against pressure from both ends of the valve with a means of venting, bleeding the cavity between the sitting surfaces. Now, we talk a lot about positive isolation. It's a method to totally isolate equipment or a section of a plant from a live process wherein no leakage is tolerated due to the risks involved. A risk assessment should be performed to develop an appropriate isolation scheme. This is very, very necessary because sometimes when you want to work on an equipment and you close a valve to isolate it, and then you go to the equipment and start work there, maybe try to open up the flanges, you'd notice a hiss of high pressure, meaning it's not been depressurized, and which could be very dangerous because a high pressure gas coming out with you there could either it could lead to very a hazardous scenario, either fires or like you being exposed to high pressure. So you don't want that. You want to positively isolate before you start work. Okay, let me go now to the needle valves. Needle valves. These are really, really tiny valves. Okay, so let me show a picture of it. And let me explain, give a definition. A needle valve is a type of valve with a small port and a threaded needle-shaped plunger. It allows precise regulation of flow, although it is generally only capable of relatively low flow rates. So what it does is when you want to have precise control over the flow of the fluid in the piping, you use a needle valve. So you can open it very slightly, you can open it very, very gently, and it gradually, there's a needle in it that just allows the flow to go in very, very gradually, slow, should I say, increments, so you can actually control it to a very, very precise degree. So that's what needle valves do. Look at it here. So this is the needle. So as you're raising it up, it allows the flow to go through very, 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 very slowly. You can increase it very gradually. It allows very, very precise control of flow across. So that's what we call a needle valve, and this is the logo for a needle valve here. On the PNID also, we would see that needle valves are used, but they're not used like everywhere. But they're still they're still very, very useful when the it's needed to be used, but you don't see them being used every day. So then I want to come to what we call a pressure relief valve. Now these valves are like they're a protection against overpressure. What they do is let me give should I say should I it allows a relief valve is a type of safety valve used to control or limit the pressure in a system. So the pressure might otherwise build up and create a process upset. If you don't have that, and there would be no way to relieve it. So most times this is what they are, and they have to be calibrated. In most countries, every 5 years they have to calibrate it to ensure the set pressure is achieved. For let me give a better definition, or let me give a better explanation. Okay, now this is to show it's been properly calibrated. And so let's say you have a vessel of, let me say, operating pressure is 2 bar and design pressure is 10 bar. So when sometimes there might be process offsets which allows if the normal operating pressure is 2 bar and it's the vessel sees a pressure of about, it's going to 7 bar, 8 bar, 9 bar, and then it hits 10 bar. At 10 bar, the integrity of the vessel will be compromised. It could rupture. There could be failures in the in the instrumentation in the pressure vessels. So you don't want it to hit that pressure. So you have a relief valve on top of the valve on top of the vessel that anytime it's set to release the extra pressure, the gas in the system, anytime it sees close to 10 bar. So anytime you're getting close to 10 bar, this relief valve pops open and it allows the pressure to go to the flare. It's always connected to a flare line, a vent line, and it allows the pressure to go there and get burnt off on the flare stack. This is very, very necessary. It is a line of protection. It is normally seal rated because you don't want this failing. You don't want to be at a very high pressure reaching your design pressure and then this valve doesn't answer you. So you have to seal rate it, which means that's the safety integrity level, meaning the failure it shouldn't fail. It's going to be designed in such a way that it fails if it's rated SEAL 3 rated, SEAL 4 rated. It fails 1 in 1,000 times, 1 in 10,000 times, 1 in 100,000 times, depending on how critical that equipment and the system is. You don't want this failing at all because it can lead to something catastrophic and a hazardous situation. So yeah, that's what safety valves are about. And yeah, this is kind of how it's on the PNIDs. They're always on vessels. Now let me go down and look for a vessel it's on. You see them on vessels a lot. It's very, very necessary because, so look at this vessel now. Uh, yeah, this is a relief valve here. So flow coming in from here, going in here. This is normally, let me say, what's the operating pressure? There's a design pressure of 15 bar. So this will be set about close to 15 bar, or also it could be set for a fire case scenario, which is when there's a fire you want it relieving earlier than normal, and then it could be also set for just over pressure. And so it's at 15 bar, that's the design pressure, and that should be about what this is set to. So when this vessel starts seeing more than 15 bar, this opens up and relieves to the flare. Okay, is this going to the drain? That might be a little design error on this PNID. I'm not too sure. I have a thorough look at it some of the time, but normally it relieves to the flare and allows the extra gas to be burnt out. And from there, we're going to be looking at vacuum valves. Vacuum valves are also essential in the oil and gas industry. And what they do, they act kind of like PSVs or pressure safety valves, but relief valves. And but what they do is they kind of work like in the opposite direction of what a relief valve would do. Like sometimes these vessels, when there's been there's nothing in them, they could actually collapse and implode. A vessel like this, or just a normal vessel, it could actually implode if there's no pressure in it. So that is a situation you don't want. It could actually squeeze up. So those vacuum valves actually allow air to go back into the the vessel to maintain the pressure in it so that it doesn't implode. They're very necessary. They're they're used a lot. And sometimes there's a combination of the pressure relief valve and the pressure and the vacuum valve. They Some valves do the same. They work in both ways. They allow the flow to go out. They allow pressure to come in. They allow when there's overpressure, they allow gases out, and when there's a vacuum, they allow gas or air back into the vessel. So yeah, that is a vacuum valve. And then I want to also talk about control valves. Now, control valves are very, very necessary. Also, yeah, before I go too far, I want to talk about normally opened and normally closed valves, and also we have locked open and locked closed valves. This is the symbology for normally open and normally closed. Uh, if you if it's normally open, it will be like this, and if it's normally closed, it will be like this. Now let me go to a vessel. It will be shaded in black, although various companies have the way they want theirs to look, but um, a lot of companies too, they like, now you can see this is shaded in, so it means this are closed, 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 and then these are not shaded in, so these are open, open, open. And then a lot of companies also do what they call lock open, lock close. So the lock a valve open or the lock closed, which means there's actually a physical device which the like a chain and a lock which allows you, restricts the opening or the closing of a valve. They put a chain and a lock on it, and there's a key with the supervisors, which when there is supposed to be maintenance or any work done on that, those valves are very critical, and that's why they lock them open or closed, because you don't want people going there inadvertently opening them or closing them. It could lead to major process upsets, it could lead to fires. So you have the keys, and then you have to get a PTW, that's a permits to work, so actually open those valves or actually close them. So they're like, sometimes they're like in that position for years. So yeah, let me give a little. So what you want in such a situation is that you don't want those valves opening or closing by people just going there and making an error, because you have so many valves around, and if the P&IDs are not read well, and the labeling on the tags on the valves are not read well, you might actually have them mistakenly opened or closed. Now, so that's talking about opening or closing valves. Although there are valves which are normally opened and normally closed, those normally opened ones, they are just white, and the normally closed ones are just black. But then you have locked open, which would have LO, and you have locked closed, which would have LC, just abbreviations for locked open and locked closed, respectively. So you don't want that kind of situation. You should be able to easily identify them to avoid a situation um, where you have a valve open or closed in the when it should be the other way around. Then also I want to go to what we call fail open or fail close. This is very, very necessary when you're dealing with control valves. Now, control valve allows flow to be started or stopped and adjusted as necessary to ensure that operations continue as scheduled, meaning they open and close automatically. You don't have to be there for them to open or close. All the valves we've been talking about, except the relief valve and vacuum valves, actually work. Those ones are automatic, but the other valves, you actually have to go there and actually open or close them. Whereas control valves are controlled either by a logic or either by you, by the operator in the control room actually pushing a button or doing something to let that valve open or close, meaning it can be controlled remotely from the control room. Now, a lot of time they are controlled by instruments, air, or electric signals, and you don't want them to fail. Sometimes you could lose a signal telling them to open or to close. So they would have a failure mode, which is, if they lose signal, the safest place for them to be is the failure mode it would go into. So some are designed to fail in an open position like this, or some are designed to fail in a closed position. And that's what this arrow pointing up means, it fails in an open position, and this arrow pointing down, it fails in a closed position. So you, when that happens, you want this to fail open you want it to feel open or you want it to feel closed. They've been designed that way. So if it's a valve that feels closed, you would see an arrow pointing downwards, meaning if it loses a signal, electric signal, pneumatic signal, instrument, the valve would automatically close without you having to do anything. And if it's fail open, it will automatically fail. It will automatically open when there's no signal going to it. That's very, very important when dealing with control valves or motorized valves. So let me show you a kind of picture of what they look like. Control valves. I have an actuator on top, which is like, should I say, place where there's, should I say, instrument air, or uh, a device on top which actually allows it to open or close without you actually having to do anything. So this is what a control valve looks like. Air to open control valve, it will open up, and air to close control valve, it will actually close down. You can see that it will open up, it will close. That is very, very necessary in dealing with control valves. And these control valves, they have various uses. There are some for flow, so they restrict flow in it could actually fully open, fully closed, and it could actually be like breathing, opening gradually and closing gradually, depending on how the process is going. It would flow, it would allow flow to go through, or allow, or it will stop flow totally, or open, or let flow, it will open totally and let the through the bore, let enough flow go across, and it could be partially opened. And yeah, so these are control valves, and they're very, very necessary in the oil and gas industry. So it could be used for flow, it could be used for also it could be used for pressure, it could be used for level. So sometimes you see flow control valve, you see this is what they kind of look like, although various companies do have their own symbology for it. You can see them, but it's just a valve with I could be either be a square, it could be a rectangle, or it could be a circle, showing that this is actually controlled. And a lot of times it is tied to a logic. A logic is like, okay, this is a pressure control valve, so this is what actually controls it. This logic, it takes a reading from here and it tells this, should I open more, should I close more, should I open more, should I close more. So that's how a pressure control valve works. Also, there's some that work for level. Pressure mainly is associated with gases and the level of pressure in the system. Yeah, okay, sorry, that's a tank. Let me go upwards. I want to look for a level control valve. There should be one here. This is just a normal PNID. I just grabbed it from one of my old works. Uh, a lot of times, like, this is a level transmitter, and this would actually control what the level like let me go to another one. I'm trying to pick up a vessel here where I could explain actually. Oh, there's no level control valve here. Okay, but I showed you a pressure. They are all like the same, but if it's level, it's going to be at the bottom of the vessel or at the liquid outlet of the vessel, and you see them arranged here to actually control the flow. This doesn't have much liquid going into it. It's mainly gas, and when the level gets too high, someone will actually come here and open the valve and let it flow out to the server pit or to the drain. And so that's how this works, because this would mostly see gas. It's a condensate storage day tank. So that's why it's in this arrangement. But they all work in the same way: pressure control, flow control, level control. Level would just control the level of the liquid in here. Pressure would control the flow coming in of flow of gas coming in here, or the flow going out. And a flow valve would just control the amount of flow or volume of liquid going across. So that's what control valve does. And then finally, we have a shutdown valve. Shutdown valves are they have this big actuator on top, and they're like saviors. Like if there's any process offsets or any issue on the plants, the the shutdown valves automatically close their valves and lock in pressure. They lock in liquid, they lock in pressure, and don't allow because if there's a fire further down the line, let's say this is a shutdown valve here, and there's actually a fire somewhere. Should I say let's assume this is a shutdown valve somewhere here. Yeah, this is a shutdown valve. Let me zoom on it. Zoom on it. This is a shutdown valve. So, for instance, this is a flow to our open flow station, and you are coming from here. So let's say there's a fire at open flow station. You don't want to continuously feed the fire with hydrocarbons. So this would automatically pick up a signal. It's normally connected to it would normally be connected to the fire and gas detection system, and once it picks it up, it would automatically start closing. A lot of times they close an inch per second. So depending on the size of the valve, if it's a 10-inch valve, in 10 seconds it should normally close and stop all flow to this, which would actually start the fire and help in actually killing putting out the fire. So you have them all across major equipments because you want to protect those major equipments. And in facilities generally, you don't want flow. This is another one here. You don't want flow going to where there's a fire. You don't want to constantly feed the fire. So you use shutdown valves for that. You also use them for pressure ups for offsets in the. You also use them for offsets in process offsets. You put a shutdown valve there. To if well, for whatever reason there's a process offset, you have alarms going off, and this could actually stop that by stopping the flow, and okay, the whole plant has been shut down. You could have a unit shut down which is just around an equipment, or you could have a total plant wide shutdown, which would be the entire facility shutting down. So yep, so that's it on this. Is also a shutdown valve. It's a lot of times it is upstream and downstream major equipments, and also and the entrance in the entrance and the outlet pipelines of a process of a process plant. So that's it. Thank you very much once again. I've explained about valves. If you have any question, of course, reach out to me. My name is Toby Famutimi. You can call me T-Fams, and I'm a safety engineer. You should subscribe to my channel, please. And yeah, you have lots of good content coming up. Thank you very much for taking the time out. Have a lovely day. Bye-bye.